All right, so today for our first lesson, we're going to start with a little basic review of a little bit of geometry and a little bit of algebra. But we're going to look at the distance and midpoint formulas of points. So first of all, we got some vocabulary, which talks about first the rectangular or Cartesian coordinate system. And basically that is just our XY graph. Okay, if you heard the word Cartesian graph or rectangular coordinate system, it's just this two-dimensional space with an x-axis and a y-axis. And if I were to put down a, a coordinate, the coordinates of a point, this is actually a location. So this tells us how far to go along the x-axis, and this tells us how far to go along the y-axis. So left, right, up and down. Also, a little bit of fancy vocabulary. The x-coordinate is called the abscissa, A-B-S-C-I-S-S-A, and the y-coordinate is called the ordinate, O-R-D-I-N-A-T-E. It's funny because they always start off with this fancy vocabulary that we'll see, and usually we will never call them that. Going forward, we're usually going to say the x-coordinate or the y-coordinate. Then we have the quadrants. And if I put a graph here and we have the x-axis and the y-axis intersecting in what we call the origin, each of these four spaces are called quadrants, and we usually name them by using Roman numerals. So I would say this is quadrant 1, this is quadrant 2, and I'm going in a counterclockwise direction, in a circular direction, quadrant 3 and quadrant 4. Okay, quadrant is 4 spaces that are made by the x and y axis. All right, so then we're going to look at the distance formula. And the distance formula, it's given here. If I want to find the distance between 2 points, point 1 and point 2, this says I'm going to take the x coordinates of those points, subtract them, and square them. And I'm going to add the difference of the y-coordinates of those points. So subtract the y-coordinates, square them, add them up, and then take the square root. All right, so here's an example. It says to find the distance between the points 1, 3, and 5, 6. So I can call this point 1 and this one point 2, and it doesn't matter which one is which. And if I apply this to my formula, if I call this point 1, the 1, I'm going to write this over here, 1, 3. So this is the x coordinate of the first point and the y coordinate of the first point. And if my second point is 5, 6, 5 is the x coordinate of the second point, and 6 is the y coordinate of the second point. So again, I'm subtracting the x coordinates, and it doesn't matter which way I go, 1 minus 5 or 5 minus 1. Let's just do it this way. I'll do 5 minus 1, it just keeps it positive. And then I'm going to square that difference, and then I'm going to add to that the difference of the y coordinates. So I'll take 6 minus 3, and I'm going to square that value, and let's simplify that. 5 minus 1 is 4. I'll square that. 6 minus 3 is 3. I'll square that. This is 16 plus 9, which is 25. And I'm going to square root that. Whoa, can't see. All right, so I'm going to do the square root of 25, and we get 5. And some of you remember that when we take a square root, we have a positive and a negative value. But since we're talking about distance, we always will have a positive value. So here our answer is 5. All right, so here's another one. X1 and Y1, X2 and Y2. And my formula, I'm going to subtract the X1 and X2 values. So subtract the X coordinates. So I started here and I worked back. So I have 3 minus -4. And I'm going to square that. And then I have 2 minus 5. 2 minus 5, and I'm going to square that. All right, so we have to be careful when we're adding and subtracting with negatives. 3 minus -4 is positive 7. 2 minus 5 is -3. And I'm going to square each of these. And notice anytime I'm squaring a number, I'm always going to end up with a positive, two positive values that I'm adding together. All right, so this would be 49 plus -3 times -3 is positive 9. And this is the square root of 58. Now we should try to simplify our square roots if we can. And by that, I don't mean to change this to a decimal. I mean, let's see if there are any perfect square factors. So if I take the number over here, square root of 58, and I just do a little factor tree. Factors that go into 58 are 2 and 29. Neither one of these are perfect squares, so I can't simplify this any further. And in here, I just have prime numbers. So the square root of 58 is our answer in simplest form. Okay. On the next page, I kind of got a head start here. It says to consider the points A, B, and C. And I actually graphed them so that we can see what they look like. And anytime you're given a problem like this, I really encourage you to put the points on a graph so that you can just get a relation of in your mind of where they are. And here it does tell us to plot each points. Find the distance of each side of the triangle. So I'm going to have a triangle here if I connect the dots. Here's one side, here's the other side, and here's the third side. So we're going to find the distance between the points, and we're going to verify that it's a right triangle, and we're going to find the area. So we got a lot of stuff going on here. Before we can verify it's a right triangle, we need to find the lengths of all the sides. So I have the side from A to B. So I need to find the distance between those 2 points. So I have to subtract, we're going to use our formula. I'm going to subtract the x coordinates. So I have 2 minus -2. And I'm going to square that. And then I have 3 minus 1 for my y coordinates. And I'll square that. So this gives me 2 minus -2 is 4. Square it, I get 16. This is still in the square root sign. And I'm going to add that to 3 minus 1 is 2. And squared that, I get 4. So the length of side AB is the square root of 20. Now, I can simplify that to, if I just kind of up here, I have a perfect square factor that goes into 20. That's the square root of 2 times this, I'm sorry, that's 4 times 5. and the square root of 4 is 2. So simplest form is 2 square root of 5. And that's the length of side AB, 2 square root of 5. Then I have side BC, and if I use those values into my formula, I have 3 minus 2 squared plus 1 minus 3 squared. So this gives me 1 squared is 1, and then I'm going to add to that 1 minus 3 is negative 2. I square that. Negative 2 times negative 2 is positive 4. So side BC is the square root of 5. All right, so I can label that over here. Square root of 5, that's in simplest form. And I have a third side AC. And if I take the coordinates from A and C, just looking up at the top here, I have 3 minus negative 2. 3 minus negative 2, and then 1 minus 1. So this gives me 3 minus negative 2 is 25, or is 5, and then I'm going to square this to get 25. And then also in here I have 1 minus 1, which is 0 squared plus 0. So this is the square root of 25, which is 5. So I've labeled my 3 sides. So I've found the distance of each side. Now I need to verify that it's a right triangle. Okay, and if you remember how you verify for a right triangle, you need to use the Pythagorean theorem, which means that a squared plus b squared is c squared. And I'm running out of space over here, so I'm just going to do this on the top. Now, it doesn't matter which side is a squared or b squared, but it does matter which side is c squared. And c is the hypotenuse, which has to be across from the angle, which would be a right angle. So this would be the angle that I'm assuming is the right angle. So this is the hypotenuse. Okay, so these two sides, I can call this side A and side B. And technically, if I want to, oh, I'm not going to do that. Never mind. I can call this side A and this side B. When I plug them into the formula, I'm going to have the side A, which is 2 square root of 5, and I'm going to square that. On this side, I have B, which is the square root of 5, and I'm going to square that. And multiplied to squared and added has to be the square of the hypotenuse, which is 5 squared. If I do some simple math here, I'm looking at 2 times the square root of 5 times 2 times the square root of 5, which is 4 times 5, which is 20. Whoops, I already squared it. So that's 20. The square root and the square, they undo each other. So if I square a number in the square root, I have this base number here, which is 5. And that equals the hypotenuse squared, which is 25. So that checks. That means because the Pythagorean theorem works, this is a right triangle. So we found that it was a right triangle, and I'm just making sure I do all the pieces here. Then it says to find the area of this triangle. All right, so finding the area of a triangle. If I remember the formula, I'm just going to kind of go over here, is 1/2 times the base times the height. All right, so if I look at this triangle, and I'm going to write this a little bit different over here. My hypotenuse is 5. This side is the square root of 5, and this is 2 square root of 5. Whoops. Up here. Okay, so I just kind of flipped it because I'm showing you that because this is perpendicular, it's a right angle, so it's perpendicular to the base. The height of this is the square root of 5, and the base is 2 times the square root of 5. So I'm going to have 1/2 times the base, which is 2 square root of 5, times the height, which is the square root of 5. Okay, so 1/2 of 2 is 1. So I have the square root of 5 times the square root of 5 is square root of 25, which is 5. So this would be 5 square units. And that would be the area. All right, so another thing we're going to look at here is the midpoint formula. And the midpoint formula tells us the location of a point that is halfway between two other points. And again, this should be a review of geometry, M standing for midpoint. And I have a midpoint that's going to be written as a coordinate, X and Y. And if I take the 2 points, I'm going to add them up, the x coordinates, and divide by 2, and that will give me the midpoint x coordinate. And then I'm going to take the 2 y coordinates from the 2 points, add them up, divide by 2, and that would be the midpoint y coordinate. So here's 2 points, and if I just plot them to give me a visual, I have 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5, here's -5, 5, so this is point 1. And then I have 1, 2, 3, up 1, and this is point 2. And if I connect them, I'm going to have a line segment, and I want to find the exact value of the point between them, the coordinates of that point. So using the formula to find the midpoint, I need to add the x coordinates and divide by 2. So the x coordinate here is -5. The x coordinate in point 2 is 3. So I have -5 plus 3 divide by 2. Now I do the same thing with the y coordinates. 5 plus 1 divide by 2. And if I do these calculations, -5 plus 3 is -2 divided by 2 is going to be -1. 5 plus 1 is 6, divided by 2 is 3. So the location of the midpoint is at the point -1, 3. And if I plot that on my graph, -1 up 1, 2, 3, there is my midpoint, which is halfway between points 1 and 2. Nice and easy first lesson.